the beginning of time, each passing age has left behind some vital knowledge that has helped make this world of ours a better place in which to live. Knowledge that has made possible the countless conveniences we all enjoy today. We look upon them as our natural right, take them for granted, and once having used them, give no thought to days gone by when people did without even the simplest of all these hard-won benefits. Yet, nothing in today's wonderful world has come to us perfect from the start. Every development has been advanced through relentless, never-ending struggle for improvement. Transportation has sprouted wings to whisk us over the span of a continent in the space of a few pleasant hours. Today, the iron horse travels faster and smoother in lighter, streamlined form. Voyage by water now provides all the comforts of home in huge, swift luxury liners. The automobile has come of age, offering speed, safety, ease, and dependability undreamed of only a few short years ago. Communication has made equal strides, improving its earlier marvels and developing newer miracles, like radio and television, that add to our pleasure and welfare. In the world of industry, modern machinery lightens man's labor, lifts giant burdens far beyond mere muscles, frees hand and eye for still greater skill and precision. Yet today, as for ages past, the constant search for improvement continues. For time is the greatest factor of all true progress. Time and its ever-increasing heritage of knowledge. And in this march of civilization, one great force has steadily contributed more and more to our material welfare. Today and for the years to come, the world looks for better things, for better living, through chemistry, the science that has played a major part in the perfection of practically everything we use, the science that has carried us beyond the machine age, on into a world of new materials that are not found in nature. And throughout the entire chemical industry, no name more honored than DuPont, contributor of many products that make life more secure, more beautiful, more livable. Among others, products like Duco, whose glistening, durable beauty of finish complements the mechanical perfection of modern motor cars. DuPont cellulose film, sold under its well-known trademark, cellophane. DuPont dyes that brighten up our lives and the clothes we wear and everything about us. DuPont plastics that give new form, beauty, and permanence to countless familiar objects. DuPont neoprene, man-made rubber that fills many uses beyond the ability of nature's own product. DuPont rayon that makes life more luxurious, more beautiful for everybody, everywhere. Rayon backed by more than a century of DuPont chemical research. An outstanding gift of chemistry, rayon has swiftly climbed to the forefront of fashion within the space of a few short years. Today, rayon fabrics enhance luxurious creations from fashion headquarters here and abroad. Today, no other textile fiber makes so many types of cloth as rayon. Sheer fabrics, heavy fabrics, rough fabrics, fabrics that are bright, fabrics that are dull, fabrics that wash perfectly, fabrics that dry clean beautifully, that cut, tailor, and fulfill every other textile duty for which each is suited. Just as with silk, wool, linen, or cotton, all these properties depend on how each fabric is made, its construction, dyeing, and other finishing operations, as well as the quality of the yarn used. The fact that rayon yarn successfully meets the requirements of textile makers and users is one great reason for its rapid growth and wide acceptance within the space of comparatively few years. Hundreds of millions of pounds of yarn are required each year to meet the ever-growing demand for rayon fabrics. Today, rayon brings new beauty and luxury within the reach of everyone, for every apparel use, in every room of the home. Woven, knitted, braided, in exquisite textures, patterns, colors, rayon fabrics brighten practically every household in the civilized world. A product of test tube and retort, it is obvious that better rayon means better chemistry. Rayon by DuPont enjoys a heritage of leadership unsurpassed in the chemical industry. Rayon by DuPont sets the pace of textile progress with its promise of still finer, still better things to come. Many of us think of rayon as a type of cloth or fabric that comes in a wide variety of textures, weights, and finishes. Actually, It is the basic material from which such fabrics are made. Just like wool, linen, cotton, or silk, rayon is a true textile fiber. Each individual hair-like fiber is called a filament. When a number of filaments are twisted or laid together, we have a yarn, which may be woven, knitted, or formed in other ways into fabrics. Like all other textile fibers, rayon has its own individual qualities and properties. Since it is man-made under scientifically controlled conditions, it is the most uniform of all textile fibers and can be varied to great advantage in its construction. For example, rayon filaments are continuous, can be produced in great lengths, and may be made finer than those of the silkworm or thicker than horsehair or coarse wool. In addition to long continuous filaments, rayon is also produced in short uniform lengths, usually from about 1 to 6 inches. This is known as rayon staple fiber. DuPont was the first company to make rayon staple fiber on a commercial scale in the United States. The use of rayon staple has increased tremendously in the past few years, largely because of the new and unusual fabric effects made possible by its short fibers. Textile mills spin rayon staple fiber, an outstanding example of the versatility of the rayon manufacturing process, into yarns known as spun rayon. Fabrics made of spun rayon have a distinctive woolly feel, pleasing softness to the touch. Sometimes spun rayon yarns are used alone, and sometimes they are blended with other fibers, such as cotton, wool, or flax. Rayon yarns may contain any number of filaments. Usually the range is from 13 to 270. For example, here are 5 specimens of rayon yarn, all the same size. Yet, notice the wide variation in the number of filaments contained in each. Sample number 1 is composed of 10 filaments. Number 2, 20 filaments. Number 3, 40 filaments. Number 4, 60 filaments. And number 5, 100 filaments. Rayon yarns provide fabrics in a wider range of weights and textures than those of any other textile fiber because of this close control of uniformity in the size and number of filaments desired. Another great advantage is that white rayon remains white. It does not yellow with age. Positive control of luster is also possible with rayon. There are brilliant yarns, more lustrous than silk, semi-lustrous yarns with varying degrees of brilliance, and yarns that are completely dull in appearance. These properties are absolutely permanent in rayon because they are chemically ingrained before each tiny filament is formed. With DuPont, rayon's versatility reaches new and unusual heights. When the need arose for a rayon yarn with special characteristics, not then possessed by any other rayon, DuPont developed a yarn to meet the need, Cordura. The cords used in making automobile tires demand exceptionally high strength as well as resistance to heat and flexing. Cordura rayon yarn fills these requirements so well that large quantities are used annually both in truck tires and tires for passenger cars. Its strength and uniformity have also brought about its use in the sails of racing yachts and for other purposes in which unusual properties are required. In the manufacture of rayon, there are 3 different methods generally used: the viscose process, the cellulose acetate process, and the cupramonium process. It is important to bear in mind that yarns made by all these processes are rayon. While each has its own different characteristics, generally speaking, these concern the maker of fabrics far more than the user. The viscose and cellulose acetate processes, both employed by DuPont, account for approximately 95% of all rayon produced in the United States. Some fabrics are made entirely of viscose process rayon, others entirely of acetate rayon. The 2 types of yarn are also combined to make many distinctive fabrics with pleasing color effects and designs. For example, this piece of undyed white cloth is made entirely of viscose process rayon. And here is a dye particularly suited to the fabric on the table. When properly dyed, the cloth colors completely and evenly a solid color. This piece of undyed white cloth is made entirely of acetate rayon. And when properly treated with the dye shown in this flask, it too takes on a beautiful, even, solid tint, as the dyed sample reveals. The piece of undyed white cloth in the center is made of both yarns. When the two dyes are mixed and the cloth is dipped into the combination dye bath, an interesting two-color pattern is the result. The viscose process yarn takes on color from the dye for which it has an affinity, and the acetate yarn is affected by its particular dye. This principle, called cross-dyeing, enables rayon to provide countless contrasting color effects, both in all rayon combination fabrics and in fabrics made of rayon and other textile fibers. From all this, we begin to realize that both yarns are extremely valuable and distinctive additions to the limited group of other important fabric sources: linen, cotton, silk, and wool. Both are rayon, a man-made textile fiber that has opened up new fields of textile beauty and utility. As with other sources of textile yarns, nature supplies the principal raw material from which rayon is made: cellulose. Cellulose is the main constituent in all plant life. If we examine a tiny cross-section of vegetable matter under the microscope, we see a series of minute chambers or cells joined together by a binding substance. The walls of these cells are made of cellulose, which must be obtained in a very pure state before it is suitable for making rayon. That means all other materials have to be carefully and thoroughly removed. In finely equipped laboratories, each lot of purified cellulose is carefully analyzed by a series of thorough chemical tests. The highest standards are rigidly maintained, and none but the best cellulose gets by these exacting technicians. The extreme degree of skill and care employed here ensures fine cellulose, the only kind of cellulose from which fine rayon can be made. The methods of making rayon by the viscose process and the cellulose acetate process differ widely, but in both cases, manufacturing can be roughly divided into three major steps. First, cellulose is changed into liquid form. Second, the liquid is drawn out into very fine streams. And third, these liquid streams are changed into solid filaments and combined into yarn. To get a rough idea of how these changes are accomplished, let us quickly run through the steps involved in the manufacture of viscose process rayon. We begin by softening the cellulose in a solution of sodium hydroxide. After a proper amount of time, the cellulose is squeezed to remove excess liquid. The soft, moist pulp that remains is known as alkali cellulose. Next, the material is thoroughly torn up into crumbs, which must be aged for many hours, during which chemical changes take place. Then the addition of a liquid called carbon bisulfide causes another chemical change. The batch shrinks in volume to about half its original size. Its color gradually changes to a brilliant orange, which gives this step its name, xanthation. When the orange-colored crumbs are dissolved in water, containing a small amount of sodium hydroxide, the result is a syrupy liquid, much like honey in appearance and flow, called viscose solution. This is the spinning solution. So far, we have seen nothing that looks like a textile fiber, but when we drop a slender stream of the spinning solution into a hardening bath, notice what happens. It congeals immediately, changing from a liquid into a flexible cellulose thread-like material, a crude form of viscose process rayon. In producing rayon by the cellulose acetate process, the spinning solution is made in an entirely different way. When the solution is exposed to the action of warm air, the acetone evaporates, leaving a solidified substance, a crude form of cellulose acetate rayon, which, as its name implies, is a chemical compound. While these rough demonstrations reveal the basic steps of the two processes and their differences, actual manufacture is a complicated and elaborate development of these apparently simple steps. Every operation must be precisely controlled. Extremely fine limits of time and temperature must be maintained. Every ingredient used must be of high purity. Proportions must be exactly calculated. When we consider that every detail must be carried out with laboratory precision, it becomes obvious that only a great chemical organization can produce huge quantities of rayon yarns of DuPont quality. The size alone of the 4 DuPont rayon plants gives some idea of the amount of specialized equipment and scientific craftsmanship needed to produce each year millions of pounds of fine rayon yarns. Yarns that are converted by leading textile mills into fabrics that make garments, draperies, and countless other fine articles found in the apparel and home furnishing departments of stores all over America. Actually, these buildings are not factories, but giant laboratories where skilled technicians follow specifications as high as those required in small experimental equipment. Within these walls work craftsmen to whom quality is a creed, with the most modern equipment obtainable. The interior of this DuPont cellulose acetate rayon plant reveals a maze of intricate, elaborate apparatus. A labyrinth of containers, mixers, and other machinery, linked by a network of pipes and valves. To the layman, a picturesque puzzle of queer-looking objects of every shape and size, but in expert hands, precision instruments that play major roles in the production of fine rayon yarn. Here, nothing is left to chance. Constant control of every process is maintained by accurate devices that check and record every operating factor. Continual checking and testing throughout every step of the way is one big factor in DuPont quality. These laboratories dot every building. Examine the product of each important process. Make sure that nothing passes on for further treatment until it measures up to the high standards set and rigidly maintained. Manufacture of viscose process rayon begins by steeping or soaking sheets of cellulose, the first step in changing them into the spinning solution, as we saw in the laboratory. But while the principle is the same as with the glass beaker, here the operation of steeping is carried out with exacting precision. Just the right amount of cellulose is placed in each compartment of the specially designed steeping press. The sodium hydroxide solution is checked repeatedly to be sure it's just right, and the sheets are allowed to soften and soak for a definite predetermined length of time before an automatically operated hydraulic ram begins to squeeze out some of the liquid. Its pressure is carefully governed so that the sheets will weigh just so much more wet than when dry. Even the weather in this room, as in all other operations, is man-made, perfectly suited at all times to this particular process. Every factor that can affect the ultimate quality of the rayon is scientifically controlled to a fine degree. The soft, pulpy sheets pour through chutes to the floor below to be shredded into crumbs. These ingenious shredders gently crumble the sheets, pulling them apart, but not grinding them. This machine also uniformly distributes the liquid remaining in the cellulose so that its action is the same on every crumb. On the floor below, the crumbs are poured into steel cabinet-like containers. Here the crumbs are stored for aging under constant temperature. Every container bears an accurate record of its contents, so it may be individually checked and controlled. Accurate scientific analysis determines when the right degree of aging has been reached. At the correct stage, the crumbs are released from storage and passed on to the next treatment, which we remember is the addition of a liquid that changes them in color from white to orange. In actual manufacture, this process is carried out in huge rotating churns that are individually cooled to a precise temperature. The snow-white cellulose enters the barrel-like interior of the churn, which contains a pipe through which carbon bisulfite is fed. This liquid flows into the churn, rotating at a definite rate of speed, perfectly blending with the crumbs, which gradually darken in color. Here again, close control of every factor is absolutely necessary if our cellulose is to make fine rayon yarns. The speed of the machinery is closely regulated. Exact timing is highly important. For proper air conditioning, the air is completely changed 22 times every hour. When the process is finished, the cellulose xanthate, or orange-colored crumbs, are emptied from the churn. Notice how greatly they've increased in size and darkened in color, an indication that they are now ready to be converted into the spinning solution. In the laboratory, we carried out this step by dissolving the crumbs in a solution of water and dilute sodium hydroxide contained in a glass beaker. In the plant, the spinning solution is made in huge cylindrical mixing tanks in which exact proportions of the ingredients are accurately maintained. Each lot produced is thoroughly analyzed by control laboratories located right in the plant. All DuPont rayon yarn enjoys uniform, high quality, mainly because its quality is never taken for granted. It is constantly tested and proved throughout every step of its scientific manufacture. To ensure the highest possible degree of uniformity in the spinning solution and in the finished yarn, the various lots are blended together. Each huge blending tank is equipped with positive stirring blades that thoroughly mix the solution. At this point, the desired degree of luster in the finished yarn is also permanently fixed. If brilliance is wanted, the blended solution is used without further treatment. The addition of a special pigment or certain types of oil changes the solution so that the yarn it produces will be dull in appearance. The amount of delusterant added determines the final degree of dullness in the finished yarn. After blending, the spinning solution is allowed to ripen for an exact period of time to bring it to just the right condition for spinning. Unless it is properly aged, the yarn it produces will suffer in quality. So, during its stay in the aging tanks, the solution is regularly tested and checked. In precision-built presses, all foreign matter is completely removed by thorough filtering, not once, but again and again. Throughout every stage of manufacture, the purity of the spinning solution is constantly safeguarded. Each piece of equipment is constructed of metals specially selected to resist corrosion and contamination of the products being handled. The pipelines, valves, tanks, mixers, and other machines are designed and built to make the purest and finest spinning solution that science can produce. The only kind of spinning solution that measures up to DuPont's high, rigid specifications before it is approved for spinning into top-quality rayon yarns. The actual spinning of the solution is one of the most fascinating operations in all industry. We saw previously how a thin stream of the solution changes to a coarse strand of crude rayon when dropped into a hardening bath. But the crude rayon formed in this way is entirely unsuited for making cloth, as can be readily seen by comparing it with true rayon yarn. To make this yarn requires a specially designed, precision-built apparatus that is an outstanding example of modern machinery. The liquid passes through still one more filter before it emerges from minute openings in a tiny nozzle called a spinneret. How fine are these openings? Well, generally they range in size from 5/1000ths to 2/1000ths of an inch, the thickness of a human hair. Each hole forms an individual filament, and there may be any number, up to 400 or more of them, in a single thimble-like spinneret. Notice how the liquid solution coagulates when the spinneret is lowered into the spinning bath. An expert hand skillfully leads the yarn through a series of guides up and around a rotating glass wheel, then down through a funnel into a whirling pot which collects it. Each thread-like filament forms immediately as the spinning solution leaves the holes in the spinneret. The speed of the glass wheel largely determines the thickness of the yarn, although this characteristic also depends upon the size and number of the spinneret holes and the amount of spinning solution forced through them per minute. The collecting pot rotates at a very high speed, from 6 to 10,000 revolutions per minute. The rotation twists the filaments together, and the yarn is distributed alternately from top to bottom, so that it will lie properly against the wall of the pot to form a symmetrical cake. When removed from the pot, the cake of rayon consists of about 29% yarn by weight and 71% spinning bath liquid, which must be removed. At predetermined intervals, a cake of fine quality yarn is removed from each one of hundreds of spinning machines. In other plants, DuPont acetate rayon is spun by yet another method. The spinning solution, made from cellulose acetate by a different chemical process, known as the cellulose acetate process, is forced through tiny holes in a spinneret located about 15 feet above the level of the floor. When the solution passes through a column of warm air, one ingredient, acetone, evaporates, and the liquid solidifies to form slender filaments of rayon. By the time they reach the bottom of the warm air column, the filaments are perfectly dry. Here they are collected and guided out of the column to a device that winds the yarn on bobbins. The acetate rayon yarn, as it comes from the spinning machine, is a finished product. After twisting, it is ready for weaving or knitting into fine fabrics. Each bobbin is numbered for easy positive identification, so that every bit of yarn can be traced back to the machine that made it. All DuPont viscose process rayon is also carefully marked for reference before passing on through the finishing operations. Repeated thorough washing with pure warm water gradually softens and cleanses the yarn and gives it a smooth, pleasant feel. Much of the moisture is removed in a specially designed machine called a centrifugal extractor. Each cake is placed in an individual chamber which spins like a top at extremely high speed, throwing off water without harming the yarn's fine texture and construction. Final drying is accomplished in automatic tunnel ovens through which the yarn travels on conveyors. An exact degree of heat is maintained so that the yarn is dried gently and slowly. Now the yarn is ready for winding into the form desired by the fabric manufacturer. The bobbins are so designed that at each stage of the processing, strain is eliminated. This permits proper tension in twisting, coning, tubing, and skeining. From raw material to finished product, all DuPont rayon, whether made by the viscose process or the cellulose acetate process, is continually checked by a rigid testing routine. A continuous check on winding tension is made by periodically testing the tension of the running yarn. Specimen cones are regularly picked at random and rewound on a special machine that permits thorough inspection of the continuous yarns. A highly trained operator expertly examines the rayon as it passes in front of a black background that easily shows up any imperfections. Still other precision-built testing appliances make sure that the physical qualities of samples of every lot measure up to DuPont's high standards. Testing for yardage is accurately accomplished by a winding reel that turns at an exact degree of speed and measures the yarn precisely. Measured specimens of known length are then weighed on a sensitive gram scale to ensure the uniformity of the yarn. The amount of stretch or elongation of any textile material, as well as its tensile strength, are both of considerable importance because they affect the serviceability and wear of the fabrics made from it. This testing device precisely records the amount of twist per inch in any given specimen of yarn. The construction of practically every type of fabric greatly depends on how the yarn is twisted, so uniform twisting is highly important. Inspection of the yarn as it passes over a strong light within a dark room is still another DuPont control. By the expert eyes of skilled operators, any imperfection is immediately detected. Nothing but perfection gets by. But with this organization, careful surface inspection isn't enough by any means. Thorough microscopic examination tells the additional story of what's beneath the surface of the yarn. Cross-sections of samples from every lot produced are prepared by making tiny wax candles with a strip of yarn forming the wick in the center. The candle is then accurately cut into paper-thin slices, each of which contains a tiny cross-section of yarn for its core. When a slice is placed in a powerful microscope and the focus properly adjusted, the structure of each tiny filament is plainly revealed. To the untrained eye, such a picture means nothing. But to the DuPont expert, the size, shape, and arrangement of every fiber tell a definite story about the quality of the yarn being tested. Notice the difference between lustrous rayon and dull rayon as revealed by the microscope. The tiny specks of pigment in the sample on the right are embedded within each individual fiber, a permanent part of its basic structure. By scientific preparation and analysis of photomicrographs of specimens of yarn from every lot produced, the quality of the yarn is constantly safeguarded. Even when it has passed every other test, all DuPont rayon is carefully checked again before shipping. To you, this skein inspection may appear hurried and haphazard. But with these girls, years of training in knowing just what to look for have made hand and eye supersensitive to any possible defect. No single cone, skein, or tube leaves any plant without this final thorough checkup. From beginning to end, one hard and fast policy dictates and controls the outcome of every operation. Test and check, check and test, every step of the way. From the raw materials to the finished products, nothing is taken for granted. The result of each process is scientifically analyzed by accurate, fact-finding equipment in the hands of experienced, capable technicians. It takes plenty of time, skill, painstaking care, and effort to follow such a procedure in large-scale production. But that's the only way fine rayon is made. Yarns that make possible fabrics that lend new beauty and attractiveness to clothing and home furnishings. Countless articles of distinction to be found in fine shops and department stores from coast to coast. Smart dresses for every occasion, for woman, miss, or child, made of every conceivable type of material. For lingerie and negligees, there are satins, French crepes, flat crepes, taffetas, and knitted fabrics of every type. Fine menswear, too, gains variety and good looks through fabrics made of DuPont rayon yarns. Underwear, ties, sweaters, shirts, pajamas, hose, slacks, and tropical suitings for sportswear. Leading curtain departments everywhere feature rayon marquisettes, voils, ninons, and plain and novelty weaves. In draperies and bedspreads, rich brocades, brocatelles, jacquards, reps, twills, moirés, satins, damasks, and plain weaves. And for fine furniture, DuPont rayons provide outstanding upholstery fabrics. For 1,001 essential articles of daily use, DuPont rayon yarns ensure beauty and long life. Backed by the symbol of rayon quality, pure assurance that the yarns used are made to the highest standards of quality, precision, and honest, careful craftsmanship. Rayon yarns that take a merited place beside every other important development that has added beauty, luxury, ease, and comfort to our daily lives. Rayon yarns by DuPont.